Alright, in our previous lesson on trig integration, we looked at what happened when sine and cosine were raised to an odd power, but we can also evaluate them when they're raised to an even power by using a couple of identities from the cosine of 2 times the angle. If you have the cosine raised to an even power, we want to use cosine squared of x equals 1/2 times 1 plus the cosine of 2x. And if you have the sine raised to an even power, we want to use the sine squared of x equals 1/2 times 1 minus cosine of 2x. My first example will involve the sine squared of x, and then I will go on into one that's a little bit more complex and look at the sine to the fourth. The even powers on sine and cosine are definitely a lot more challenging than the odd powers. So let's take a look at cosine squared, sorry, not sine squared. So cosine squared of x dx. Straightforward replacement on the identity I just gave you. I'm going to write the 1/2 out front because remember we can bring those constants out front of the integral. And we're going to write it as 1 plus the cosine of 2x dx. In this particular example, we can integrate them individually. The 1/2 does go to both, but the antiderivative of the 1 is simply x. Now the antiderivative of the cosine of 2x, we have to use u equals 2x multiplied by, du is 2 dx, and multiplied by 1/2, all that kind of stuff. So we end up with plus 1/2 sine of 2x, and then plus c. If you want to distribute this 1/2 in front, we can go 1/2 x plus 1/4 sine of 2x plus c. Not too bad when it's only a squared power. A little bit harder when it becomes a little bit higher power. So let's take a look at something like the sine to the fourth. We're going to write this as the sine squared squared, and so we're going to write it as the sine squared of x squared dx. Then we replace the sine squared in the interior with our identity. So, and then we're going to get into some algebra here. We get a 1/2 in front, and then we have 1 minus cosine of 2x. Close that parentheses, and then square it, dx. Got to make sure to square this 1/2 out front as well. My next step, I'm going to square it out, so I'm going to take that 1/2 and square it, and it's 1/4, and I'm going to put that in front of the integral because I like to pull my constants out front, definitely. And then inside here, I've got to square this out, and when I square that out, it's a binomial and it becomes a trinomial, so I get 1 minus 2 cosine of 2x. Okay, that one's not a problem. What we can do is we can integrate that by letting u be 2x again. But then we're going to get plus cosine squared of 2x dx. And here's where the problem comes in, because now we have a cosine squared, which we have to go back to our previous example just a moment ago and replace that one with its identity as well. So these first two, the 1 and the minus 2 cosine of 2x, not too bad, but that cosine squared causes some problems. So let's do it. If I take the antiderivative, I have that 1/4 out front there. The antiderivative of the 1 is x, and then that's going to be minus the sine of 2x. It's minus the sine of 2x because that's going to be the antiderivative of that cosine of 2x. And then I'm going to write this second one, the second part of the integration, as 1/4. I'm distributing that 1/4, and then it's the integral of the cosine squared of 2x dx. So what I did was I took the antiderivative on the first two terms, but I did not on this third term. That 1/4 I did distribute though. So now I've got to replace this cosine squared. That's a really bad cosine squared, but it's there. So the 1/4, this part right here, double underline, I'm going to leave that. That's going to be part of my answer in a moment. But let's just work on this statement, the second part of it for now. So 1/4 times the integral. Now I've got to replace the cosine squared of 2x, which is going to be 1/2 times 1 plus cosine of 4x, and that's my identity that I just showed you just a moment ago. Obviously this 1/2 I can pull out front, and I have 1/8. The antiderivative of of 1 is just x, and then this part right here, u is going to have to be 4x, du is 4dx. So I multiply it all by 1/4 and then multiply, all that stuff, so I get plus antiderivative cosine of sine, so 1/4 sine of 4x. And that's that integral, that second part of the integral. So then ultimately, the answer to this gosh darn question, it could be some version of 1/4 times x minus the sine of 2x. That was the first part of that integral, plus 1/8 times x plus 1/4 sine of 2x. So there you go. Now we can deal with our sine to an odd power, our tangent to an odd power, our secant to an even power, and now our sine or cosine raised to an even power. The sine and cosine raised to an even power, either to the 4th power, or if you really want to get into something challenging, raise it to the 6th power. Those are definitely the harder ones, okay? And that will take you through that first part, that first lesson on integration. You should be able to do the workout assigned to you on the first part of that trig integration. We still have a little bit more identities to talk about, and I'll do that in my next video.